Hello, in this video we'll talk about basic plotting functions to make histograms, box plots, and scatter plots, and also various arguments you can specify for these functions. Let's use the health data set for demonstration. Let's say I want to plot the histogram for the men's height. Then I have to first subset the data, then plot the histogram. Again, to subset the data, I have to first identify which records correspond to men. Then to get only the men's height, I would have to subset from all of the height values only those that correspond to the male records. I can use the hist function and pass the numeric vector men height directly into hist, and that will give me a histogram. Notice that the axis labels and the title are all set using default values. To change these default values, we can change a few arguments. To change the x-axis label, I can specify xlab to be something else. Let's say height in inches. To change the title, I can change the argument main. Let's say histogram for men height. And lastly, to change the y-axis value from plotting frequencies to densities, I can let freq equal to false. After we do this, we have our desired title, axis labels, and we're now plotting densities instead of frequencies. Let's say I want to plot the histogram for woman's height for comparison. In this case, all I have to do again is subset the correct data, then plot the histogram again. To get the woman's, I can just look for the records that are not for men. And now from the original call, all I have to do is change the title and then change the numeric vector that I pass to hist, then I'll get a histogram for woman. Notice that R automatically overwrites the previous graph. To make that not happen, you have to first create a new graphing device. Max, you can use the function quartz instead. Then, in this case, all I have to do is call the previous function for men, and now I should have a histogram for woman and one for men. One thing to notice is that the woman spans a much smaller range compared to the men histogram. This makes the two very hard to compare. To make them easier to compare, we have to put them on the same x-axis. So let's say the span for the x-axis should be the range of the entire health dataset heights. There are missing values, so we have to remove those first. And now we know that the x-axis should span from 35 to 89 inches. Now for the hist function, all I have to do is specify the xlim argument to be what we found. And now plot the histogram for women, again changing the x limit to the same x span. And now I should have a histogram for men, one for women, and notice now that they span the same area on the x-axis. Now let's talk about box plots. You can use the box plot function to plot box plots, and all you have to do is pass all the numeric vectors of the box plots you want to get the different box plots. You can also make box plots by splitting the entire health data set by a logical or factor vector, and this will determine which groups you'll split the data by and plot separate box plots for you. Notice that the axis labels were again using defaults, and we can actually specify the group names to be, well, for women and men. And to change the labels for each group, I have to specify the names argument to be the group's names. The y-axis label can be changed using the argument ylab. And again, the title can be changed using the argument main. Let's say box plots for men and women height. And there we go. Now let's talk about scatter plots. Imagine I have the vector 1, 5, and 6. To plot scatter plots, I use the plot function. If I just give it one vector, what happens is that I get 1, 5, and 6 on the y-axis, and the axis is default to the indices of the vector, meaning the first, second, then third position on the vector. I can also make the scatter plot of the health data set between height and weight. Notice that the default is that the first argument becomes the x-axis, second argument becomes the y-axis. Again, I can label the axes using xlab, so this was height in inches, and I can label the y-axis using ylab, this is the weight in pounds, and the title again is using main, so this can be scatter plot of weight versus height. Voila. Let's say I want the scatter plot of height versus weight for men and women using different colors. Again, here I would have to first subset the data of interest for the men, and for the women, I just only want the records not corresponding to men to get the right data. It's good practice to first plot all of the data so you get the correct x-axis and y-axis span. You have to specify the type equals to n so we get an empty graph. This is because we're going to plot the men and women separately later. Again, we can specify the x-axis to be pounds and the y-axis label to be the height and inches. The title will be just scatter plot for height versus weight. And here we get an empty graphic. Let's say I want the colors for the women to be in red, the men to be in blue. Then I can now add points to the empty graph over there using the points function. Here you treat it like the plot function. For the women, weight, then women height. The color will be the first color in my color vector. And PCH stands for plotting character. If I want solid circles, I can use 16. Now we can see solid red circles on the plot. To get different kind of plotting characters, you can try out different numbers. But for men, all we have to do is change the data and the points function. And here we can get blue squares instead. Now let's label this graph. To label things, notice that the gender we had and the colors we had first woman, then men. So the legend function, we can first specify the location of the legend. Then what the legend should say. We want the genders there. The colors should be the color vector we had before. And the different characters were first solid circles, then solid squares, and voila. Here we get the scatter plot labeled with correct stuff.